shift gears. I'm going to really speed through. I'm getting to the end of my time. Let's shift gears a bit and consider another extremely important issue, that of the thick sediment sequences which blanket the Earth's continents. How can so much sediment be transported and deposited in a time span of only a few months? That boggles the mind, doesn't it? Or not? Am I the only one that has trouble imagining how that could happen? Well, let me offer a new mechanism. In 2006, as I was grappling with trying to understand the continental motions during the early portion of the flood, I realized the Earth may well have been rotationally unstable during the flood as a consequence of changes in the distribution of mass in the Earth as the plates were rapidly sinking to the bottom. Such a state of instability leads to multiple rotations of the original North Pole and South Pole and back again, with the Earth flipping over and over like a top. And this kind of motion, rotational motion of any rigid body, is described by what are called the Euler equations, discovered in the mid-1700s by Leonard Euler. And so this is from a class on this phenomenon at MIT. I'm just saying this showing the geometry for the equations. These are the equations. I don't want to intimidate you by the equations, but they're actually relatively simple here. The M's are the torques acting on the body. In the case of the Earth spinning in space, there are no torques, so all these are zero. And but these are nonlinear equations. The rate of change in the spin rate depends on the product of the spin rates about the other two orthogonal axes. So it's an interesting set of equations. Possible to program it. Only took me an afternoon to program those on the computer and start getting solutions. What sort of initial condition might lead to this kind of instability? One possibility would be a ring of cold material in the upper mantle, but that is precisely the sort of pre-flood initial condition I've been using in my catastrophic plate tectonic simulations. As I showed earlier, this is roughly a ring around a great circle in the Earth, and what results at the bottom is roughly a ring, along a great circle in the Earth. So in this case, the spin would be through an axis through the plane of that circle of rock, and okay. So so I've programmed that using those initial conditions. It's possible to solve the Euler equations numerically, obtain solutions that display this behavior. And so here's an animation sequence, and let me try to help you follow what's going on. I've put a red spot at the geographical North Pole, a yellow spot at the geographical South Pole, and I have one spot, a green spot, along the equator, just to help you see what's going on. Now, I show two views here. One is that if you're just at a fixed point in space looking at the Earth, and that one is not as helpful as this one. This is the geostationary view, like a geostationary satellite, like a weather satellite that rotates around the Earth once every 24 hours and is able to stay above the same point as the Earth rotates. The satellite rotates along with the Earth once a day. And so this helps you see what's going on with the Earth and takes out the Earth's 24-hour rotation. So in this sequence that's going to follow, I urge you to look at this one. And so so what you're going to see, so this is one snapshot. This is one slightly later. You can see the green spot in the left figure moving, whereas the green spot in the other one is hardly moving. All right, so here's the animation. You can see the Earth, the North Pole flipping down to where the South Pole was. Okay, and this is the time, 12 days, 13, so on. And so this thing flips about on the order of 4 times during the main phase of the flood, the way I've got the parameters set. And it's driven, again, by the change, by what's going on inside the earth. Okay, I think we've played enough of that. My time's getting short here. Each vertical line represents one flip of the earth. I won't go into that. We can also test this numerical result experimentally. A friend in my church is an engineer. He wanted to do an experiment, see if we could reproduce this with an experiment. So we looked for balls that were very symmetric. We found that billiard balls had the best symmetry of any kind of ball we could purchase. So what we did was put some extra mass in the billiard ball. Took about 3/4 inch pieces of brass welding rod, inserted them at 12 equally spaced locations around a great circle to give us that extra mass. And then we levitated the ball using air to minimize the friction. I did that with my shop vac. And so this will show I'm just going to show you the billiard ball with the pieces of brass welding rod in it. Let me turn off my sound here. Well, I forget how to turn off my... I got it. Okay, so that's what the billiard ball looks like, and this shows it being supported and in a ABS pipe fitting with my shop vac connected, and the air causes the ball to rotate. In this case, the axis is horizontal, not vertical. I forgot to mention I paid in one end of the ball with a white spot with a black spot in the middle to denote one pole, and then no black spot on the other end. So you're going to see the ends of the billiard ball exchange places here. Okay, I need to click on this. So here you see this moving away from the pole, and the white spot on the other end moving toward the equator. Now they're both going basically around the equator. The white spot moving down to the other pole, to this pole. Okay, and then they move back again. Just like the computer simulation showed. You know, some people don't trust computer results, so this is for those of you that are in that category. It's the air. It's there's enough asymmetry in the ball to cause it to spin one direction in preference to the other. Okay, so I think you get the idea there. All right, how would such rotational dynamics affect the water in the oceans? Can you imagine what the oceans would do if the Earth flipped like that? Well, I'll give you a hint what it happens. It produces gigantic swirling masses of water thousands of feet in depth that migrate over the continents. Super tsunamis. Instead of the tsunamis being a few tens of feet high, we have them like 1,000 feet or 2,000 feet high, and not instead of moving at 10 miles an hour, the water, the free velocity is on the order of a couple of 100 miles an hour. Now, just to help you understand why that is likely, right now, the Earth rotates once every 24 hours. The circumference of the Earth is about 25,000 miles. So on the equator, the water and the people and buildings, everything is moving at about 1,000 miles an hour to the east. Now, if you suddenly move the equator up to the North Pole where it's not moving at all, you've changed the velocity of everything by 1,000 miles an hour. So it's not surprising that, you know, some of the water's all of a sudden going to find a continent in its way where it hadn't been in its way before. And you can well imagine water spilling up over the continent. Okay. All right. So here are some snapshots from a simulation I've done. This is with a computer program I developed while I was at Los Alamos. Solves the shallow water equations on a rotating sphere with a variable topography. And so I have in this case, I've put a single circular continent on the sphere that's and the water depth initially, without any rotation, is 100 meters, 300 feet. So that it's flooded by 300 feet of water. Elsewhere, the water depth is about 12,000 feet. And so, again, I use a view where the camera is centered above the continent at all time. So you're taking out all of the rotation and other things. So you're just centered over the continent. We're simply interested in how much water, what's going on above the continent. The color denotes the height of the water height above nominal sea level. So the maximum value is 900 meters, which is approaching 3,000 feet, and the minimum shown here is 100 meters. About it's the original surface height of the continent. And so the velocities are going to be on the order of a couple of 100 meters per second. So that's one snapshot. You see this swirling mass of water this way. One thing is that when these blobs of water occur when the continent is near one of the poles, in this case the South Pole. And when it gets around, when it flips the other way, the rotation direction is opposite. So these are for meteorologists in the room. These are like high pressure regions, so the rotation is clockwise in the northern hemisphere, counterclockwise in the southern hemisphere. So this is a little later in the sequence. This is just showing, this is snapshots a day apart, showing how these things move from day to day. All right, now this is the animation. This is the time in days, 35, 36, 37. So here's a blob. Here's another blob, the one we just looked at. Here's another blob, and here's yet another big blob. And they're opposite in polarity and direction. And this is the last one after about 190 days. Then I start this sequence over again. So what are some consequences, astonishing consequences? The rotational instability of the mantle during the flood appears to provide a potent means of generating large-scale currents on the continents capable of transporting and depositing vast quantities of sediment demanded by the stratigraphic record. What are the next steps? Work is underway to add an erosion and sediment transport and deposition model to the shallow water program currently used. The output from this enhanced program will be a layered sediment sequence over the continental regions. So we can run this simulation, look at what the sediment pattern is, and ask, is there any resemblance to what we see today? So I'm very eager to see what the answer is going to be. So what is the takeaway message? Well, the Genesis flood was real, radically transformed the face of the earth. Should be obvious. And just meekly say, it appears feasible to apply scientific methods to gain insight into some of the important physical aspects of the cataclysm. So I believe this kind of work is worthwhile. And finally, compared with God's wisdom, we're hardly scratching the surface. As the Apostle Paul says, "Oh, the depths of the riches, both of the wisdom and knowledge of God, how